Trying to fix my view. Okay, so good afternoon, everyone. Today, our group will present our analysis on the impact of monetary policy on Calgary's rental market in 2026. So, housing affordability has become a growing concern across Canada, with Alberta experiencing some of the most significant challenges. According to Statistics Canada, the rising household costs are impacting both the homeowners and renters. Calgary's housing market, in particularly, has undergone rapid changes driven by a combination of population growth, economic shifts, and regional development. The increasing costs are straining household budgets and creating a complex environment where policymakers need to understand the underlying factors influencing the rental prices and availability. So this situation um, underscores the importance of conducting a policy analysis for future housing strategies. Since 2022, the Bank of Canada has been raising interest rates quite sharply to control inflation. These increases make borrowing more expensive for everyone. As a result, fewer people are choosing to buy, and the demand for rental housings has shifted upward. This has affected vacancy rates and rental prices across the country, including Calgary. What we want to understand is how these macroeconomic policies, interest rate changes, are actually impacting the rental market here today. So, our goal is to explore the connection between the Bank of Canada's interest rates and rental markets outcomes in Calgary by 2026. Some key questions for our research is how does the Bank of Canada's policy rate predict rental inventory in Calgary? Our secondary question was, does the sensitivity to interest rate differ between full homes and apartments? And is there a statistically significant lag between rate changes, rate change and rental price response? Our second key question was, what is the impact of property features on rental prices? After controlling for size, does the share segment still offer lower rents? And our final question was, can landlord incentives like rent discounts or free months be predicted based on market conditions? Particularly, we looked at how incentives vary across rent segments and whether incentives are more common in high vacancy segments. And then, do you want to do the presentation for yours, or should I
Yeah,
just do?
yeah, I can do this part. Okay,
Okay.
so thanks, Bhuvan, for the introduction, and now we'll be moving on to the methodology. So you're probably wondering, how did we answer those questions that Bhuvan mentioned? So we started off with data collection from different sources. We used APIs and data sets. So we did connect to like Rent Faster, for example, and another website from Bank of Canada to get interest rates. Then we did data cleaning and merging for consistency. So this was pretty important because the data wrangling basically organizes the data and gets rid of null values. We had some feature engineering where there was some segments, there was graphs, there was lag variables, and then we went into statistical analysis and modeling where we made some models on regression, correlation, and we looked at the b values and different variables and what kind of impacts they had on each other. And then, yeah, lastly, we had some visualizations that we'll probably show you in the PowerPoint for insights and interpretation. So we'll be going over our data collection and technical workflow now. So how did we collect all this data? You may be wondering. We did have a scraper engine. So there was automated collection via web scraping. There was a system delay of like 2 to 3 seconds because RentFaster was blocking this scraping, and we covered basically 5,525 listings from a RentFaster API and a Bank of Canada API. What's in the pipeline? Obviously, we cleaned the pipeline. The specifics are we use JSON Lite for flattening, the janitor library for cleaning, and then Coalesce for robust column mapping. There were some merging, like we had the Bank of Canada interest rates merged with the monthly rental snapshots using the Lubridate library, and then we had some feature engineering done to create different segment categories and flags. So data sources and variables. So what were our different data sources? So interest rates been mentioned a couple of times. We had the monthly policy interest rates from Bank of Canada. We had rental listings from RentFaster, which specifically looked into certain bands and features of the property, like number of bedrooms and size of bedroom. We did scrape some things from housing and economic data from the Canadian Real Estate Board, Area and Stats Can. So there was a little bit of scraping done there. And then what were the important variables? So rental price obviously was very important. The size of the bedrooms, the property size. We did have some indicators from the landlords about rent discounts. Some months might have been free. So different incentives to basically get that property. And then there were some lagged variables. And for data preparation, so the first thing that we ran into was that there were some issues with the date. So we had to standardize these dates into this year-month format. Then there was lagged interest rate variables to look at delayed effects. Definitely the duplicates had to be removed because some didn't have listing IDs or some came up twice. And then we also addressed missing data with either interpolating or extrapolating and removing certain data. The key goal was to ensure that there was consistency across the data set, so we would have good merging of the joined data and graphs as a result. So for our EDA and visualization, you'll see there'll be a histogram for distribution of Calgary rents with segment overlays. These were the key stats that came from this histogram. The median rate was $750 to pay for shared rooms. For apartments, it was $1,500. For full homes, it was $2,150. The key insight here is that there's an inventory at a 3-year high. So a lot of units, 5,500. So this shows a very high supply. For certain visuals that we made, there were scatter plots, heat maps, and box plots, what will show up in the next slides. So I'll definitely talk about the analytical techniques as well. What analytical techniques we'd use. Definitely use regression to check the relationship between interest rates and prices. From our regression analysis, we noticed that there was a lagged effect 1 to 6 months between interest rate changes and rental prices. It makes sense because one variable is changing and it takes time for the other variable to be affected. And then we did use logistic regression in addition to our primary regression model to look at any likelihood of landlord incentives affecting the market and in what frequency. And yeah, these visualizations will come up. So what was our first research question? I'll pass it on to Bhuvan to cover this part.
So our first objective is to determine whether changes in the policy rate of the Bank of Canada predict rental supply in Calgary. So the hypothesis was that interest rate influences rental supply, with higher rates potentially reducing demand for home purchases and increasing the rental inventory. To test this, we used the simple linear regression model, where we looked at rental inventory relationships with policy rate. So we created a scatter plot showing the relationship between the Bank of Canada's policy rates and rental inventory levels in Calgary. So this plot shows the clustering of rental inventory around a policy rate of 2.25%. So no clear trend indicates a direct influence of interest rates on rental supply during the period. So our regression results indicate that the coefficient for the policy rate is close to 0, and statistically insignificant. This suggests that during 2026, changes in the policy rate did not have a direct impact on the rental supply in Calgary. So, using a cross correlation analysis, we examined the whether rental prices respond with a delay following interest rate adjustments, and our findings point to a lag of approximately 3 to 6 months, meaning that the market takes some time to adjust to monetary policy changes. This insight emphasizes the importance of considering time delays when evaluating policy impacts. In summary, short term interest rates shifts did not significantly predict rental inventory, while rent prices show delayed responses of about 3 to 6 months. Instead, local supply surges and migrations trends played a more prominent role.
So thanks, Bhuvan, for presenting the first research question. I'll move on to the second one. So we were looking at property features and rent prices and seeing if they have any sort of correlation. In this one, we looked at a multiple linear regression. So we're basically seeing if the final price is affected by beds, square feet, and the segment. So let's see, what did we find out? So you can see we have our model here with our BO, y-intercept variable, epsilon, and our different variables listed. The final price is shown as 650.99 as the coefficient, times the final beds and the rest of the coefficient. We do have several variables. The R squared is only 3%, so it shows a poor fit. And we also see that the model is, the p-value is higher than 0.05 for the f-test, so it's not statistically significant. The regression coefficients aren't statistically significant either. So there isn't a very strong correlation necessarily, but it was still good to look into and analyze. We do have a visual here of box plots of rent by bedrooms and the property type. So we can see in this graph there's an upward trend of the median rent increasing with the number of bedrooms, which would make sense. We could have guessed that before seeing the visuals. Full homes also have a higher median rent than apartments and shared units. So we can see that the full home is in green and the apartment condo is a kind of orange type color. And there's a lot of different greens which have a higher price in this chart here. In the next graph, we see the impact of features and market intercorrelations. So we can see that there is a negative impact with segment shared, but there is a positive impact with the final beds, like number of beds, and the segment of a full home. And there is some correlation. We see like certain correlation coefficients here. Final beds has a correlation coefficient of 0.554, and then final square root feet has a correlation of 0.668 with the final bed. So there is a bit of a correlation that we can see. Key takeaways: larger properties and more bedrooms will command higher rents. This was pretty predictable and according to our calculations. Size and bedroom count alone are weak predictors, so they need to be compared along with other predictors to see if there's any sort of effect. There are other factors like location, maybe the type of neighborhood, or whether it's close to suburban or rural might have an impact. And certain amenities, like what kind of features are offered within the homes, might have an impact. And just to summarize, like our model had an R squared of 3%, so low predictive power, and then regression coefficients were not statistically significant. So this is going to be Bilal's part, but I might just wing his part to get a sense of time here. So the third research question was landlord incentives and market conditions. So we want to predict incentives based on rent and segment. And to do this, we used a logistic regression model. The binary outcome comparison was incentives versus no incentives, and the variables we used were rent price and property segment. So what did we see? We see a chart here with number of listings and different types of segments of full home, other, and shared. And we do see the blue one, which is the other category, has a high segment for listings. So they have like about 400 to 500 listings in other. And we see that shared is around to 150. So we did see that lower rent levels significantly increased likelihood of incentives. There are certain incentives that are more common in lower rent segments, for example, shared units and apartments. So, what can be taken from this? Market competition affects landlords and it drives them to offer incentives in budgets. Okay, so price range by property type. This is another visual incentive. Distribution across segments. Higher incentives in less than $1,000 rent segments. So in the shared category over here. And there's less incentives in the full homes, which is up here in the green. So the violin plot shows where most of the density was. So you can see that the width of the violin plot is what affects the density. So for the summary of this, incentives are more prevalent in lower priced, high vacancy segments. Landlords were using discounts and free months to compete. We did see this in some of the research articles when we did our background checks. And higher price segments are less likely to offer incentives. So moving on to the overall market insights. Segment sensitivity, full homes are more volatile as compared to shared units, which are more stable. There is a lag effect. Rent prices respond after 3 to 6 months to rate changes. And there are market drivers like supply surge, property size, and segment preferences, which dominate at different times. Policy implications, we should focus on increasing family size units and understanding delayed effects. This is going to be especially important in Calgary because the population is increasing and there's a need for a shared home and accommodations. But yeah, that was the overall insights we saw. And there were some limitations of the study that were there as well. So there were some external factors like migration and utility prices. Apparently, there's talk about a data center in Calgary, so that might affect the utility bills as well, but that's a different study. So, what were some assumptions our models followed? We looked at normality, and it's usually normally distributed for the graphs in multicollinearity. And then we were limited to specifically 2026, so we can't really predict any longitudinal trends. We should be able to compare different neighborhood specific analysis that might be us getting information from like a real estate agent or a rental website that could give us that information, but that would be a future direction. In conclusion, we saw that interest rates changes in 2026 had limited immediate impact on rental supply. Supply surge was affected by local factors for the most part, and rental prices did get influenced with the interest rates, but had a delay, especially for larger properties. Landlords have certain incentives to respond to market competition, especially in the lower segments. So that's what we noticed for the most part. So what would be our next steps and recommendations? We could develop a neighborhood geographic information system mapping for better insights, so we know how each neighborhood is affected by the interest rates and the amount of people migrating in. There could be an Aeromax model to forecast certain 2027 rental trends. We could add additional variables like utility costs, like maybe water costs as well, with the main breaking, and migration costs, and then use these findings to inform housing policies, especially for family size units. And final remarks, we have a quote here: data driven housing policy is the only way to navigate Alberta's boom and bust cycles. So there are a lot of cycles of peak, recession, trough, recovery, and growth. And we'll continue to see this happen, maybe fluctuating along with oil and gas cycles as well. These are our references, and thank you for coming to our presentation.